molecule that's kind of like a go-to in chemistry, water, right? So let's go ahead and I'll show you what I mean by lone pairs. And then we'll kind of also tie in polarity, since you mentioned that that you're kind of struggling with what that is, right?
Mm.
So you understand how this is a line diagram compared to if I did Lewis dot, right?
Right.
So you notice how these orientations are representing the same thing,
Mm.
right?
Mm-hmm.
Yes, good. Okay. So on the periodic table, I don't know if I can show you the periodic table. Okay, so periodic table. I should have had this out knowing I was going to do chemistry today. Silly goose. Okay, so I'm going to kind of switch back between the whiteboard and the periodic table.
Mm.
Let's see. All right, so it's kind of small, but you see where oxygen is, right?
Mm-hmm.
Okay, great.
Wait. I can't see the period. I thought you mean the oxygen on the whiteboard, because I can't.
No, sorry about on the periodic table. Yeah, let me bring up a bigger. Yeah, this is my fault. I should have brought this up once I knew that I was gonna have a student that. Let me pull this on the image. Okay, so I'll refer to that periodic table in a minute. Let me go back to the whiteboard. Okay, all right, so we've already established that the top molecule and the bottom molecule are representing the same thing, right?
Mm-hmm.
However, what is the bottom molecule missing? And the top, rather. What are we missing?
The other, like the electrons that are not.
Yeah. So you're missing the electrons. Hello? Hello? Are you there? Okay, sorry, I missed you. But I think I heard you said that you're missing the ones at the top, right? As well as the bottom, right?
Oh, I said like we are missing the valence electrons that are not sharing.
Right. So those are called lone pairs. So whenever you have those pair of electrons that aren't being attached, that aren't being shared by another molecule or another element rather, then that is a lone pair. So at the top, let me use another color here so you can see it. So at the top here, that would be a lone pair, that would be a lone pair, that would be a lone pair, and that would be a lone pair. Okay?
Mm-hmm.
Does that make sense? So anytime you see molecules that aren't being shared, those are lone pairs. And so if you were to ask to be drawn a water molecule and you're using Lewis dot, you would use the one that's at the bottom. Okay? And the reason why is because hydrogen, how many electrons is around hydrogen itself?
One,
right? And so that one is being shared right here.
right.
Okay, so we'll actually undo those circles. Okay, so with regards to hydrogen, this is hydrogens, right? And same thing on this side, right? Right? Okay, but everything else, these 1, 2, 3, 4, 5, 6, that belongs to oxygen. And so when we look at our periodic table, oh my gosh, it's so tiny. No. Oh man. Okay. But anyway, can you see it here?
A periodic table, right?
Hello? Hello?
Hello. I think I lost you.
Yeah, okay. Yeah, I'm not sure why. It's very weird. But anyway, but you see where oxygen is, right?
Mm-hmm.
Right here. So if you count from the left side of the periodic table, you count 1, 2, we skip the transition metals, 3, 4, 5, 6. They are in this column, which represents the fact that it has 6 electrons on that Lewis dot. Okay, which is consistent with what I showed you, right? Right. So that's how we know, go back here. that is how we know how to draw the structures. And so anything that isn't connected to another molecule would be
Mhm.
considered those pairs that aren't connected to another molecule or another element, that would be considered a lone pair. Does that make sense?
Yep.
Great, awesome. Okay, so let's actually